Welcome to MRU E-Learning, powered by Malla Reddy University. My topic is Machine Learning, Fundamental Basics from Data to Intelligence. So myself, Dr. G. Balakrishna, Associate Professor, Department of Computer Science and Engineering in School of Engineering, Malla Reddy University. My presentation overview, we have the introduction and machine learning landscape and data, the fuel of machine learning. The overview, I can picturize like this: deep learning, reinforcement learning, and unsupervised learning, supervised learning, and data, the fuel of machine learning and machine learning. So that's why first I will concentrate on the centric point of machine learning. I will concentrate. So what is machine learning? A subset of AI in the sense artificial intelligence, that enables the systems to learn from data to improve from experience without being explicitly programmed. In the traditional programming, we have the inputs plus rules is equal to answers. In the machine learning approach, data plus answers is equal to rules. So in 1959, Arthur Matt Samuel is quoted as machine learning is the field of study that gives the computers the ability to learn without being explicitly programmed. So we have, there are three concepts, AI, deep learning and machine learning. We are comparing that. AI is the broad concept of smart machines. ML is called as the algorithms that parse the data, learn from it and make decisions. And the deep learning is a subset of ML, utilizes the multi-layered neural network that is inspired by the human brain. So why the ML is rising? It is an exposition of data generation. Where the data is generated? The social media, IoT and sensors. In IoT devices, we are using sensors. By the sensors, it will get the data. Whereas the social media, you can see that Instagram, Facebook, Twitter, these all are called as the social media. We will get the data from there. So this is the big exposition of data generation. That is called big data. So if you want to computing the data, you can use the computing power. That is called as GPUs and cloud computing. Making training feasible. In the sense, the GPUs are called as the graphics processing units, and cloud computing, if you want to store the data, from the data you can computing using the graphics processing units. Improvements in open source libraries, TensorFlow, PyTorch and scikit-learn. So now, how the machines to learn? The concept about the pattern recognition. So analogy, how to teach a child to recognize a cat. In the traditional programming, what you want to do that, you can define the rules. You have ears and mosters and tail, like that you can tell that and they will identify. But whereas in the machine learning, you show that the child, 1,000 pictures of cat, 1,000 pictures of not cats. Then the child figure out by the features themselves and they will find that which is cat, which is not cat. So next one is machine learning landscape. In the machine learning landscape, we have three types of the machine learning. One is supervised learning, another one is unsupervised learning, another one is reinforcement learning. Supervised learning, that is learning with a teacher. That is in the sense, if you want to label the data, you can learn, that is called as the supervised learning. Unsupervised learning without a teacher, that is unlabeled data, that is called as unsupervised learning. Reinforcement learning, learning by trial and error method. You can give a reward or punishment, that is called as the reinforcement learning. First, we discuss about supervised learning overview, labeled data, input X and output plus output Y, that is called as the labeled data. While learning the mapping function from input to output. The two main tasks, the predicting continuous value. For example, you can say that house price prediction. You can use the continuous value day to day. It will be increases like that. So that's why there is a continuous curve will come. That is called regression. Classification, you can to predicting category. You can have if you have emails, if you have either the mail is spam mail or not spam mail, you will be predicting by the classification algorithm. Unsupervised learning overview, you can have the unlabeled data. We will give input X only. So the goal is the finding hidden patterns or structures in the data. So the key task is the clustering the data. That is grouping the similar items and the dimensionality reduction. That is the simplifying the data. For example, you can see the example. The librarian arranging the books in the genre without knowing the book titles. beforehand. Next, reinforcement learning overview. It is called as state and actions. Maximize the reward function. For example, agent interacts with the environment, take an action, receives the reward or penalty, and update the policy. So, analogy can give the example of training a dog. If it is good behavior, you can give the reward. It is a bad behavior, we are not given any reward or not rate. So, what is the data? Data, the fuel of ML. It is a pipeline of the ML pipeline. So, whereas data collection, data pre-processing, model selection, training, evaluation, and deployment or development. So, you can see that data pre-processing. Data pre-processing, why it matters? The garbage in, garbage out. If your data is messy, your model will be bad. So, if it is a real world data, it is incomplete, noisy, and inconsistent. Key steps of the cleaning and transformation and reduction. These are the 3 steps you should follow while you are doing the data processing. So, you can see the data cleaning. Data cleaning, we are handling the missing data. Delete the rows, fill out the mean or median. If you want to fill with the mean value or median value. Handling noisy data. Removing the outliers. In the sense, anomalies of the don't fit in the pattern. Example, for example, height data set. The height of the data set contained the value of 200 feet. Clearly an error. Discussing about data transformation. Normalization or scaling. Bringing features to same scale. For example, you can say that if your age will be 0 to 100. Income will be 0 to 1 lakh. Why? The large numbers are often dominate the learning process. So, encoding, the converting the text to numbers. For example, if you are giving the colors, red color will be 0, green color will be 1, blue color will be 2. Why? Because the machine should understand the numbers only, not for the text. Splitting the data, the golden rule, they never test the data you trained on. So, here the training data will be 70 to 80%. The textbook used it to study. That is, the study itself is called as the training. So, validation, practice exams to tune knowledge. For example, that is for validation, we can give 10 to 15%. Testing data, the final exam, that is called a testing data, that is unseen data will be tested. Next is supervised algorithms, learning algorithms. So, first one is linear regression. In detail, we will discuss the fitting the best straight line through data points. Use case, predicting the house price, sales forecasting. These are the use cases while you are using linear regression. What is the analogy? For example, a gardener notices that every extra cup of the fertilizer, the plant will grow 1 inch. So, for example, if we are they drawn a line predicting the growth of for 10 cups. Then we get a line. So, logistic regression. This is for classification. The concept of dispute the name. It's for classification. Predicts the probability 0 to 1. Using a S-shaped curve. So, the use cases are spam detection, disease diagnosis. Here, yes or no. The analogy you can see that a doorman deciding the someone entering into the club, it will be 1. It is if it is not entered in that is value will be 0. So, based on the what? The dress code is the probability. Dress code probability. If it is a proper dress code, that will be 1. It is not, that will be 0. Next, decision tree. The flowchart like structure. The splits data based on the questions. For example, the analogy you can say that for in a game have 20 questions. Is it an animal? Yes. For example, does it fly? No. Does it bark? It is a yes, you can give the answer. Finally, they will detect that the animal is dog. Next one is random forest. The concept of the random forest, an ensemble method creates hundreds of decision trees and merges them. The logic is the wisdom of the crowd. One tree might be wrong, but 100 trees averaging, their answers are usually right. So, the risk assessment, the stock market prediction. These are the use cases. Risk assessment and stock market prediction. Next one, support vector machine. Find the hyperplane, the best separate 2 classes with the maximum margin. For the example, that means called analogy, the drawing a widest possible median strip between two lanes of the traffic so cars do not crash. This is the analogy that is called as the road separation. Next one. Next, K nearest neighbors concept. Show me your friends, I will tell you who you are. That is the one concept. You can say that. Logic. Classify the new data point based on the majority classes of its K nearest neighbors. Simple to understand but slow with large data. So next one is Navy Bayes. The concept is based on the Bayes theorem. Bayes theorem is in the probability, assumes the futures are independent. Use case is sentiment analysis or document categorization is called as the use cases. Example, you can say that it's an yellow, long and curved. It is likely a banana. Even if these features are looked separately, that is we are using in sensitive analysis. The summarizing the supervised past, one is the regression examples, temperature forecasting, stock price prediction, years estimation. Then classification examples, you can see that email spam or not spam, image recognition, cat or dog, fraud detection, fraud or not fraud. These are the examples. Next one is overfitting, underfitting. The model is too simple, it did not learn the pattern. Analogy, if you are studying only book by books covers only. So the overfitting, the model memorized the training the data, including the noise. It fails on new data. Analogy, the memorizing the textbook word for word, but failing the question parsed differently. This is the overfitting. Bias variance trade-off. Bias, error from erroneous assumptions. That means leads to underfitting. Variance, error from sensitive to small fluctuations. That is called leads to overfitting. For examples, goal is called the Goldilocks zones. That is low bias and low variance. Next, unsupervised learning algorithms. Up to now we discussed supervised learning algorithms. Now unsupervised learning algorithms we will discuss. The clustering, K-means algorithm. K-means algorithm partitioning the data into K distant groups based on the similarity. So the algorithm picks the Q random centroids, assigning the points to the nearest centroids, moves the centroids to the center of assigned points, repeat it, and the use case is called as the customer segmentation. Customer segmentation, high spenders and low spenders. We can, by the credit scores, you can decide that low spenders and high spenders also. Hierarchical clustering, the concept building a tree of clustering. This is here two types of the approaches we will follow. One is the bottom-up approach, another one is top-down approach. The start with n clusters merged into closest ones. Another one is top-down approach, start with one cluster and split them up. Anomaly detection, identifying rare items that differ significantly from the majority. Use case, credit card fraud detection, manufacturing defect detection. So the logic is the data point is too far away from the others, it must be suspicious. That is the logic. The dimensionality reduction. Dimensionality reduction, the problem is curse of dimensionality. Too many features making sway and complex. The solution, that is the solution what you want to get the solution in the sense, the principal component analysis that compresses the data while keeping the most important information. The analogy, you can see the 3D photo of a teacup and flattening to it into 2D. You lose the depth but keep the shape. This will be the one is the example. Next one is association rules. The discovering the relationships between the variables. The famous example for the market basket analysis, people who buy the bread and diapers, they also buy the bear. A priori algorithm. This algorithm is a priori algorithm. Next one is reinforcement learning. Reinforcement learning, what means reinforcement is unique. What makes reinforcement learning is unique. No labeled data, no immediate correction, learning focus on long-term goal, delayed the gratification. So the key terminology we can use that agent, environment, action, reward and state. Agent, the learner. If can example as Mario. The environment, the world, that is the game level. You can give the action, move left, jump back. This is the actions we can take. Another one, reward points. Reward points we will allot, staying alive. And state, what the agent is currently. That the state of the agent will decide. The RL applications, the reinforcement learning applications, robotics, robots learning to walk without falling. That is the one application. Another one is gaming AlphaGo, beat world champion in Go. OpenAI 5, that is the Dota 2, that is also another application. The self-driving cars is the navigating the traffic. It is the self-driving cars is the one example for reinforcement learning applications. Now we are going for introduction to deep learning. Deep learning in the sense that is called neural networks. That is human brain. You can see that neurons and synapses. If you can see the structure, input layer, we can receive the data. Hidden layer, math magic happens here. The output layer is called as the prediction. Whether we are predicted or not predicted will be decided by the output layer. Next one is what is the difference between the deep learning and machine learning we will discuss. The feature abstraction. The humans must manually select the features. For example, tell the computer to look for ears. That is called as the human will be guide to the computer. Whereas deep learning, the network learns the features itself. The figure of the ears are important on its own. That is called as the deep learning. So data requirement. The deep learning is needs the massive data of massive amount of data to work well. Whereas in the machine learning, we need don't need the massive data. The popular architectures, convolutional neural networks, we are using the great for images and or videos. Another one is recurrent neural networks, we are using the great for text or audio, the sequence of data. We can use these architectures. Model evolution. In this section, we will discuss model evolution, the confusion matrix, a table to describe the performance of the classification model. One is the true positive that correctly predicted S. True negative correctly predicted no. The false positive we will type 1 error. False negative is type 2 error. Type 1 error is a false alarm. Type 2 error is called as the missed detection. So the key matrix you can find the accuracy. We can use the formula true positive plus true negative by total. Warning the bad imbalanced data. The accuracy is equal to TP plus TN by the formula we will use the finding the accuracy. Precision. Out of all predicted positives, how many were real? That we got as a precision. The precision is equal to true positive by true positive plus false positive. Next one is recall. Another key matrix. We can see that recall. Out of all real positives, how many did we find? We can find that recall is equal to true positive by true positive plus false negative. F1 score, that is called the harmonic mean of precision and recall. Harmonic mean in the sense 2 into precision into recall by precision plus recall. We will find the F1 score. Another one is evaluation for regression. We can use accuracy for continuous numbers. That is one is called as the mean absolute error. That is average magnitude of errors. YI is called as the actual value and YI cap is called as the predicted value. N is called as the number of samples we will take for calculation of the mean absolute error. Evaluation for regression, we can use accuracy for continuous numbers. So we can use for root mean square error. It punishes the large error more heavily. We can use that formula. Root mean square error is called square root of 1 by n into sigma. I is running from 1 to n. Yi minus yi cap. Yi is called as the actual value. Yi cap is called as the predicted value. You can see this here, actual value and predicted value. We can calculate the. Next we can have the applications and features. The real world applications, we can see the Netflix or Spotify, the recommendation engines, healthcare, predicting the tumors better than radiologists, finance, algorithmic trading and credit scoring, agriculture, precision farming, detecting weeds and pests. The conclusion and future, the future is called as machine learning about the finding the patterns in data to make predictions. What are the future trends in the sense AutoML, automated machine learning, expandable AI in the sense understanding the why a model made a decision, ethical AI removing bias from algorithms. Thank you.